In my previous video, I discussed what's called the Dirlicht function. It's given by the following piecewise functions. So it's 1 if x is rational, and it's also 0 if x, that looked like a sigma, if x is not rational. It's a real valued function. And what makes this interesting is you might have learned in an algebra class, like a college algebra class, that d of x plus a, or just in general, if you have a function and you take f of x plus a, this shifts the function to the left by a. So right, let's take f of x equals natural log of x. Let's natural log of the absolute, natural log of x. We could say that f of x plus 4 will shift the graph to the left by 4. So it will look like this, right? And the reason for this is that now if you want to get f of 0, you'll have to plug in -4 for x. But what's interesting about the Dirlicht function is it doesn't satisfy this. Another example of a function that doesn't satisfy this is all the constant functions, but those are trivial. So f of x plus a equals f of x. And that's because if we take a rational number and add a rational number, we'll get a rational number, so this output will stay the same. And if we add an irrational to an irrational, this output will stay the same. And to me, that's very interesting. And somebody were asking about periods. So, for example, on sine of x, we know that sine of theta is going to be equal to sine of theta plus 2 pi n, where n is an integer. So n is in z, right? But however, you can't really call this a period. And the reason for that is some functions do repeat. So what we mean by a period is the sine curve repeats the same pattern every 2 pi units on an interval of 2 pi, which is why this is true. But this repeats infinitely and regularly. So you can't call this a period because when some functions do have multiple periods, so they'll repeat on multiple intervals. The period is defined as the minimum of the set of intervals at which the function repeats. So like, let's say it repeats every interval 1, interval 2, ... interval n, right? The period will be the minimum of this set, right? And that's very interesting. I wonder if, and I don't know if this is true, it might make a good research paper if there are properties that could be investigated in terms of this notion of period, even though it isn't like actual period, but could be a pretty interesting research paper.